All right. So what we're going to do here, to go through confidence intervals on your calculator, we're just going to go through the two examples that we had yesterday. We're just going to talk about plugging them into the calculator, getting the answer. So we don't have to worry about interpreting or anything like that. We're just going to talk about the setup. Okay? So if we look back at this example, we were talking about NOx emissions from 40 light-duty heavy engines. Okay? So in this particular type of problem, they reported to us the sample mean and the sample standard deviation, and then told us the interval that they wanted us to create. Okay, so this was one where they just gave us the information, we had to plug it in and use it for the interval. So if we want to do that same process in your calculator, so in this case we're working with a t-distribution. So when we're working with means, we're working with a one sample t interval. So on your calculator, where you're going to find that is the same place you found the one sample or the one prop z interval. Okay? So if you go into stat, over to tests, and then when you scroll down, now you're not going to see one sample t interval. Okay? What you're going to see is just plain t interval. So on the 84, you should see that as option 8. If you have a different version, you might see that somewhere else. But what you're looking for is t interval. Okay? So when you select t interval, okay, when you select t interval on your calculator, you're going to see two different choices for input. So at the very top it says, what kind of input do you want? Do you want to do data, or do you want to do a lit or stats? Now, if you have the data, so if they actually just gave you the list of values, and you have those stored in your list, then you would use that option, because then you just have to say, I want list 1, and basically tell it to do what it needs to do. Okay? In this case, though, we don't have any of the data, we only have the summary statistics. So we're going to choose the stats option. So scroll over to stats and hit enter. And what it's going to ask for is x bar, so what's the sample mean, which in this case was 1.2675, so plug that in. It's going to ask for the standard deviation, so the sample standard deviation. Now, be careful here, because when you look at this, this is SX, which is sample standard deviation, not standard error. It will calculate standard error for you. Okay? So you are reporting only the sample standard deviation, so 0.3332. Then you plug in your sample size, which in this case was 40. Plug in your confidence level, and then calculate. Now, just to review then, on the homework or on a quiz or a test, if you were using your calculator to calculate or construct the interval, you would need to tell me that you used the t interval. You would have to tell me that you chose the option for stats. Tell me what you plugged in for x bar, what you plugged in for SX, what you plugged in for N, what you plugged in for confidence level. Okay? So you need to tell me everything that you plugged in basically like a list format if you want to. Okay? So T interval, we plugged in stats, so we gave x bar, SX, N, confidence level. Okay? Now when you calculate, so it takes a little bit longer to calculate. It should give you your interval. And so then at that point you would write down or report the interval and then interpret based on the context of the question. Okay? So when you type all of that in, you should get the same answer as we had yesterday, which in this case would have come from the calculator version of T star. So that's another thing to keep in mind. If you're checking your answers in your calculator, so if you use the formula and then you plug it into your calculator to get the answer as well, just to check, be aware that if you're someone who uses the table to get your T star, your interval will differ than what the calculator gives, because the calculator is going to use its real version of T star, where you might be using an estimated version of T star, if you had a degrees of freedom that didn't exist in the table. Okay? So just be aware of that when you're checking these out. We okay with that? Okay? So that's entering information based on summary statistics. So if they give you the scenario and tell you X bar and SX, that's going to be the method or the process you use.
So basically, if we use the calculator to do that formula, we don't need to find T star on the chart.
Right. Now, you still need to know how to do it, because the question might also ask what is the T star or something like that. But if you're just if it just says construct and interpret the interval and you're going to use the calculator, you just have to tell me what you plugged in, give me the interval, give me the interpretation. You don't have to report anything else. Okay. All right, so that's that type. Then yesterday we also discussed a type where instead of giving you the summary statistics, they actually gave you the data and you had to work everything through. Okay? So hopefully, if you go into your list, you haven't put anything new in or deleted out or anything like that. It should still be the same list because we did this yesterday, right? So if you have this same list in there, we can now do the second method for constructing an interval on your calculator. So you're going to go into Stat, over to Tests. You're going to select T interval again. And then this time you're going to highlight and hit Enter on the data option. So you need to actually hit Enter so that it converts to that mode. And then in this case, all you have to do is make sure you specify which list your information is in. So most of you should have plugged it into list 1. That should be the default. Frequency, leave alone. So just leave that as 1. Put in the correct confidence interval. So in this case, it would be a 90% confidence interval. And then hit Calculate. Okay, so when you do that, same type of deal, but in this case, there's a little less to report. All you have to tell me on this one is you chose T interval. Tell me you chose the data option. Yeah, I guess you wouldn't have to. I would just put what list you put down, just so that way it's a way for you to physically check that you have the correct list. So it's more for you than it is for me. But make sure you write down which list you chose, confidence level, and then report what you find. Okay? So when you report it that way, same type of deal. Comes up with the interval, gives you X bar, gives you SX, gives you your sample size, and so on. So then you would just report the interval, interpret it based on the scenario of the problem. Okay with that? All right. So that's the process. If you have one of the other types of calculators and you want to kind of go through how to do it on yours later on, we can do that once we get through today's stuff. Okay? So, from now on, whenever you're asked to construct an interval, whether it's for proportions or for means, you can use the formula method if that's the way you want to go about it, making sure you show your work, so how do you calculate the pieces you need, or you can use your calculator, but again, you have to report what test you chose, what you plugged into that test, and then report the values and everything that it gives you. Okay? So either way is going to work from here on. Now, what we're going to talk about today, the last little bit, is determining sample size. So remember when we worked with confidence intervals for proportions, one of the key parts was knowing if I'm going to go out and run through a sample survey, if I'm going to run some type of research project, and I'm going to construct an interval for it, I'm going to want to have in my head before I start, how close do I want to be to the actual value, and what confidence level do I want to establish. So based on those two ideas, we talked about a way to calculate the size of the sample we would need to collect in order to reach those goals. So to be 95% confident with a 3% margin of error, how big a sample do we need for that particular scenario? Okay, so we did that with proportions, now we need to do it with means. So if we try the same process, this would be our formula for margin of error. So remember, margin of error is always the total amount we reach in each direction. So that's our critical value times standard error. So if I'm using this idea and I want to collect, or I want to figure out how big a sample size I need, if I look at this formula as it is, do we see any issues? So it's the same idea as what we did before. We're going to establish a confidence level, which gets us our critical value, and we're going to establish a margin of error that's acceptable to us. So we need to solve for n. We need to know how big a sample we're going to collect. So when we look at this formula, what major flaw do we see? Say what now? Well, we will have to eventually, but what I'm saying is, if I'm looking at what I need to collect, so I need to know my margin of error, well, that's something I'm going to establish myself, right? What else do we notice here? Yeah, think about our goal in this setting. We're trying to find our sample size. We're trying to find n, right? But n will determine which t-distribution we're working with. So depending on what n value we get is going to determine what t star we get. So if we don't know n, can we calculate t star? We can't. So that's one major flaw with this formula. What's the other one? We're trying to determine how big a sample we need so that we can go collect a sample, right? So if we haven't collected a sample yet, what else can we not have calculated? Standard deviation. If we don't have a sample yet, we don't know what our sample standard deviation is going to be. So in this particular scenario, the only thing we would know is margin of error. We don't know anything else if we're using this formula. Okay? So instead of working with this information, we're going to do things a little bit differently. So to determine the sample size that will yield a specific confidence level with a specified margin of error, so to reach the goals that we want our project to reach, the first thing we're going to do is get a reasonable value for the population standard deviation. Now, generally, that would either need to be done from an earlier study or from a pilot study. So you would need to run a small pilot. So maybe you go out and gather a quick sample of individuals and calculate a quick value. Okay? Or, a lot of times, based on your project, you can look at other people's research and they will have done something similar, or they might have measured the same type of population, and they might have a reasonable standard deviation that you could use. Okay? So you're looking for an earlier value or a pilot study value that you've calculated. Now, for our types of problems that we're going to work with, that will be something they give you in the problem. So they're going to have to say, from an earlier study, we would use this value for standard deviation. So that's something you're going to get reported. But if you were doing this in real life on your own, you would have to do one of these two things. Okay? The other thing that we have to do is, since we can't use t, because t is dependent on the sample size so that we can find the degrees of freedom and know which t distribution we're working with, we have to go back to our normal distribution. The normal distribution is the same regardless of sample size. So we can use Z star in place of T star. So basically, instead of using values that we have no way of calculating otherwise, we can at least get some estimated values that we can work with to get us close enough. So now, this is what we're going to be looking at. So this is the formula we use to find sample size when we're working with means. So our margin of error will be equal to the Z star, the critical value associated with your confidence level, times some previously known standard deviation divided by the square root of n. And so from there, we plug in our values, solve for n. Okay. So make sure when you're looking at finding sample size for a mean problem, you recognize that we convert back to Z, and we need to use a population standard deviation that's been previously determined. Okay. So, let's do a quick example. Researchers would like to estimate the mean cholesterol level of a particular variety of monkey that is often used in laboratory experiments. They would like their estimate to be within 1 milligram per deciliter of the true value of mu at a 95% confidence level. A previous study involving this variety of monkeys suggests that the standard deviation of cholesterol level is about 5 milligrams per deciliter. Obtaining monkeys is time-consuming and expensive, so the researchers want to know the minimum number of monkeys they need to generate a satisfactory estimate. Okay, so we want to make sure we have the correct sample size so that we're not trying to obtain more monkeys than we need, because as I say, it's time-consuming and expensive. So, can't remember if I worked this out. Nope. We'll work it out by hand. So if we're working with this problem here, when we set up our equation, we're using this modified formula to find sample size. So we got to start plugging in values we know. So the margin of error, what margin of error do we want to have? 1, right? 1 milligram per deciliter. So margin of error is going to be 1. Z star, if we want a 95% confidence level, Z star would be 1.96. That should be one you still have memorized.
If you don't have that memorized, where would you get it from?
Inverse norm. You either have to go to the normal distribution table and look it up and find the Z-score, or you can use your inverse norm function on your calculator. And so then in the inverse norm function, remember, if you're doing 95%, the area would be that 95 plus the 2.5% the tail, so you'd actually do 0.975. And then from there, it should come out to be 1.96. Okay? So, 1.96 for Z star, standard deviation. Was 5. So we said based on a previous study, we can use the value of 5. So here's what we're looking at. So with the values plugged in, now we need to solve. So if we want to solve, we want to get the square root of n out of the denominator so we can multiply it to the other side. So we'd have our square root of n is equal to, we have our 1.96 times 5, and then we can divide by the margin of error, which in this case is 1. So all we're really doing is just a quick switch. Okay, if you want to make the algebra really quick. So we had 1.96 times 5 divided by square root of n. Well, if we want n by itself, multiply it to the left, divide the margin of error to the right, and now all we need to do is square the result to get in. So in your calculators, take 1.96 times 5, and then from that result directly, square it. And what do we get for a sample size? 96.04. So we need a sample size of about 96.04, but we can't collect 0.04 of a monkey, so we would need to go to 97. Okay, so our sample size would need to be 97 to reach our goal. Okay with that? All right. That's it.
Where did you get that?
This right here. You know what I'll do? We do second.
So the area, so 95% confidence level, it's 71, 95% confidence. So that's the middle 95. Plus, there would be 2.5% fail. Yeah, so there's 5 total on the outside, so you would go, oops, so you want to do, the total that we want would be the 95 plus 2.5. So you leave that at 0, leave that at 1. All right, so these are the problems I want you to try out. So you got the remaining time here. Use this time, either finish up yesterday's assignment. If you don't have that finished yet, start working through these problems. If you